Hello everyone, my name is Poojitha and today I am going to discuss about the topic called intrinsic and extrinsic semiconductors. First, what do you mean by semiconductor? Semiconductors are materials with electric conductivity between that of a conductor and an insulator. They are fundamental to all modern electronic devices. The importance of semiconductors are enable transistors, integrated circuits, and data technology. Examples for semiconductors are silicon, germanium, etc. In semiconductors, there are two types of semiconductors. One is intrinsic and another one is extrinsic semiconductor. Intrinsic semiconductor means it is completely pure. That means both the electrons and holes are equal in number. These are also called as pure elemental semiconductors. In this, conductivity increases with temperature. Limited practical use due to low conductivity at room temperature. Now let us discuss about extrinsic semiconductors. Extrinsic semiconductors are created by adding impurities to intrinsic semiconductors. The process of adding impurities is known as doping. The main purpose of doping is to increase the conductivity and control charge carrier types. In extrinsic semiconductors, there are two types. One is p-type and another one is n-type. Let us discuss about p-type. What do you mean by p-type? Adding third group elements to the fourth group elements is known as p-type semiconductors. In p-type semiconductors, the concentration of holes is greater than the concentration of electrons. Next, in n-type, we add fifth group elements to the fourth group elements. Examples, phosphorus, etc. In n-type semiconductors, the electron's concentration is greater than the hole's concentration. Now let us compare both the intrinsic and extrinsic semiconductors. In purity, intrinsic semiconductors are pure and extrinsic are doped with impurities. Now let us see conductivity. Intrinsic is low and they are temperature dependent, but extrinsic is high, they are controllable. Charge carriers. In intrinsic, electrons are equals to holes, but in extrinsic, they both are not equal. When we see in n-type, electrons are greater than holes, but when we see in p-type, holes are greater than electrons. It depends on the doping. Next, doping. In intrinsic, we need not to add any elements because they are pure. But in extrinsic, we are adding the elements to increase the conductivity. They are called as acceptor or donor atoms. Practical use. Intrinsic is limited, but extrinsic is widespread in electronics. Now let us see the applications of semiconductors. Both intrinsic and extrinsic semiconductors are indispensable in modern technology, forming the building blocks of countless devices. Diodes rectify AC to DC, protect circuits. Transistors amplify signals, acts as switches in digital circuits. Integrated circuits, microprocessors, memory chips, entire electronic systems. Solar cells and LEDs, energy conversion and efficient light source. From smartphones to renewable energy, semiconductors drive innovations. Thank you.